Hey everybody, so as you can see I'm out today. I'm hoping you're doing a good job for Miss Tran. Today what we're going to be working on is what is the follow-up to your tutorial, this new idea of something we call point slope form. So today it's the same goal as yesterday. We're trying to come up with the equation, but the idea being that what if we don't have the slope and the y-intercept? We can't do slope-intercept form, so we have this new way of doing things called point slope form. Now, something that wasn't in the video, you don't have to copy this down, but just in case you're curious where it comes from, this should look familiar. This is our slope formula. And basically what somebody decided to do was to repurpose this formula, which normally helps us find slope, to find the equation of a line. Basically what happened was they did this. They decided that they could get this into a different format where if they changed this around a little bit and solved for y, in other words, get these y's by themselves, they would get rid of x2 minus x1, which the opposite would be to multiply both sides by that x2 minus x1 combo. And so then these would disappear from this side, and we'd get y by itself, and then everything else on the other side. And the only way this is different in your notes is it looks more like this, where the y's are on this side of the equation, and then this is on this side. And since they were only plugging in one x and one y for both things, what they also did was they just got rid of this y2 and x2. Okay, and so this is the equation in point slope. And in fact, today what might be handy is to have this at the top of your paper so you don't have to keep referring to your notes. But the basic idea is that if you have a point, any point on the line, not just the y-intercept, but any random point, and you have the slope, that you can plug the right things into the right spots, and you get the equation that goes with that graph without having to find the y-intercept. All right, so let's see some examples. And this, you should have paper out because this is part of your work. You're just going to copy it down, follow along, just to get you a start. All right, so don't copy all this down, but why don't you copy the problem down, number 6. Write in point slope form an equation of the line that passes through the given point and has the given slope. So you have to imagine that we have some line that goes through 3, 0 and also has this slope. And we're going to find it using point slope. Now once again, point slope is this. Y minus whatever the y coordinate is, so I'm going to underline that. Whatever the y coordinate is of the point that our line goes through, that will go here. Equals the slope, which is m, which we'll underline that too, times parentheses x minus, and then whatever the x coordinate is of the point that our line goes through. So everywhere I've underlined is basically where we're just going to plug these numbers in. All right, and the one thing I want to point out before we get started is notice of all the different things we've learned, standard form, slope-intercept form, and point slope form, point slope's the only one where the equation has subtraction signs in it to begin with, unlike the others. Okay, that'll kind of become important later because people mix those up all the time. All right, so anyways, hopefully you figured out that over here on our coordinates, this will just serve as x1 and y1. It's our first and only coordinate. So we just treat that as x1 and y1, and our slope is negative 2/3. So what I do is I just plug things in. Y minus whatever the y coordinate is, in this case y1, which is 0, equals m, which is our slope, negative 2/3, times parentheses x minus, and our x coordinate is 3. Now they want it in point slope form, so I'm just going to leave it the way it is, all except for one thing. I'm going to clean up the minus 0 because minus 0 should just vanish, and so we can leave it like this. This would be leaving your answer in point slope form. Okay, and if we were to graph this, we would find that our line did go through this point, and our line would have this slope. Okay, so again, this is going from the information back to the original equation. All right, let's try another one. Here's number 8. Same thing. Here's a point that my line goes through. Here's the slope that the line has, so I just need to plug it into the right spots. So once again, it should be y minus whatever your y coordinate is, in this case negative 3. I'll put parentheses around that to separate the minus and the negative, equals the slope, which is 4, right here, times parentheses x minus the x coordinate, which is 1. All right, and again, they want the answer in point slope form, so I'm going to leave it like this. All except I think I'll clean this minus and negative up because minus and negative always turns into plus. So that'll just simplify things a little bit. All right, so that's how you do the basic ones, about understanding what point slope form looks like and where the different coordinate points and slope go into our equation. Okay? All right, now let's just jump to two that are a little bit harder, and that should be enough to get you a start. So take a look at this one and copy it down. Don't worry about the instructions, just the points. Now this one's a little misleading, so I wanted to make sure this was in the video. Write in slope-intercept form an equation of the line that passes through the given points. So you might think, and this is what's misleading about this problem, is they want us to start off in slope-intercept form, but they haven't given us the slope, and they haven't given us the y-intercept either, if you look. This problem actually wants to start off in point slope, and then later we're going to change this to slope-intercept. So on these problems in your homework, start off in point slope form. Now even then it's a little confusing, because if you think about it, point slope means we need a point and we need the slope. But if you look at the information that we've been given, all we have is these 2 points that our line goes through. So there's two things that you should be thinking to yourself right now. Well, Mr. Honda, they gave us 2 points instead of 1, and they didn't give us any slope. But then hopefully what you're also thinking about is you have a way to find slope. Given 2 points of a line, you learned back in December how to find the slope, which was that formula for slope. M equals y2 minus y1, which gives us the rise, over x2 minus x1, which gives us the run. So this would be y2 minus y1, 6 minus 4, x2, which is 3, minus x1, which is 2, which would be 2 over 1, which is just 2. All right, so now we've got a slope. But now the other question comes up, well, Mr. Honda, which point do I use? Okay, well, for these two examples, I'm going to do the work twice. You don't have to do this today, but I want you to see what's going to happen. All right, so let's take a look here. Let's say I choose to use this point, and then, of course, our slope of 2. Okay, well, then my equation is going to look like this. Y minus my y-coordinate, 4, equals 2 times parentheses x minus my x-coordinate of 2. All right, so that would be my answer. But let's say the person I'm working with right next to me, they chose to use the 3, 6 as their point. Same slope, but a different point. Okay, well, their answer is going to look totally different. Y minus 6 equals the slope times x minus the x-coordinate of 3. Okay, so just like I mentioned in the video, if you leave your answer in point slope form, we can't really compare answers. We don't know who's right and who's wrong. And so that's why in the textbook they want you to change your answer into slope-intercept form, because magically enough, despite the fact that your work here looks different, that when I do this and when my friend does this, when I put these into slope-intercept form, they should turn out to be the same answer. So let's try this. If I do distributive property, I'm going to get y minus 4 equals 2x minus 4. And then if I get y by itself by adding 4 to both sides and getting it in slope-intercept form, because that's the giveaway, y is always by itself in slope-intercept, I get y equals 2x plus 0. So just y equals 2x. Now, if my friend has done their work right and I've done my work right, when they put theirs in a slope-intercept form, they should get the same thing. So y minus 6 equals 2x minus 6. Add 6 to both sides. And magically enough, y equals 2x. Okay, so even though I pointed this out in the video, I wanted to make sure that this was clear, because you guys always work with each other, and you're going to notice this, that your work and your initial equation will look different, but once you put it in the slope-intercept form, you should get the same answer. Okay, if you don't, then definitely something's wrong. But even though point slope might look different, slope-intercept should look the same. All right, let's try one more like this one. In fact, if you want to try it out, go ahead and then just come back to this video. It's up to you if you want to pause the video and then try it out, but same thing. Let's finish up in slope-intercept form by doing point slope for the line that goes through these 2 points. All right, so first thing, find slope. So slope would be y2 minus y1 over x2 minus x1, which would be 4 over 4, which would turn out to be a slope of 1. All right, I'm going to split my paper again. Let's say I choose to use this point. So I would do y minus 3 equals a slope of 1 times x minus negative 2. And there's my answer. My partner does it this way. Y minus 7 equals 1 times parentheses x minus 2. So right now our answers look different. All right, so that's why we've been asked to put in slope-intercept. So here, well, 1 distributed just is going to disappear. So x minus negative 2, and I'm just going to clean that up too. So this whole thing will just turn into x plus 2. The minus and negative turns into a plus, and 1 times anything is just itself. All right, then I add 3 to both sides. So I get y equals x plus 5. There's my slope-intercept form answer. All right, so let's check my friend's workout. Distribute the 1, but 1 times anything is itself, so I get y minus 7 equals x minus 2. Add 7 to both sides to get y by itself. So I get y equals x plus 5. And so our answers match, so this looks good. Okay, so this is just a different technique to do the same thing we did yesterday. We're trying to find the equation of a line, but based on other information. We're going backtracking to the original equation. Okay, and this is called point slope form. All right, so keep going on the same piece of paper. We've done, that was 6 and 8. Now, by the way, I added these as extras. You actually have to do the odds on these because these I think are kind of easy. You just plug the numbers in and you're finished. So I did evens. You're going to be doing the odds in this section. But then you are going to have to do number 13, which we've done here, and 14 is also a part of your assignment. Okay, so keep going on the same piece of paper. Work at your tables today. Since you have a sub, I'd like things to go as smoothly as possible. So work with the people nearby, help each other out, and do a good job for Ms. Tran. All right? Keep up the good work, and I'll see you guys tomorrow. Okay, bye.